So sad. All right. So we're going to get into the actual differentiability rules, guys. So far, the only one I touched was power rule, which was nice, and it saved you time. That's what these are going to do as well. These are going to save you time. Mares, close it. Okay? So what this does is if we've got two things multiplied together, then we're going to be able to find the derivative without having to take the limit as h approaches 0 and do all that business, or expanding it all as well. So first thing we're going to do is review a little bit. So for this, all we had to do is use our power rule and also remember how to take the derivative of sine, which we already did. So, Nico, you were talking lots, which means you must know how to do it, right?
8x to the third.
Good. And then?
Plus 6 x.
Subtract 1. So -2 minus 1. No. We're subtracting 1, so it's -3. You got to remember, you always subtract. Even if it's negative, you're still subtracting, okay? You're always going to subtract it. All right, and the next one, Marco. Yeah, you, man. He's so surprised I called him. What's the derivative of sine? You remember? Cosine, exactly. There we go. All right, so our two derivatives are just that. It's just one that we have to memorize. I mean, I can go through a long proof, and if you want, you can go watch the AP video on how we do it, but I don't think you care. In AP, I actually go through it and we prove how it works, but I don't think you guys care, to be honest. my AP students don't even really care.
So the one that we just did, like for example, in the first question of the bell work, is the power.
This is power rule, and this is just sine and cos.
In order to find the derivative, that's what we did in last class.
Yep.
But now we're going to learn another.
Boys, too loud. Huh?
Now we're going to learn another.
Now you're going to learn a new rule, product rule. Yes.
So what we learned before, it's not going to learn.
He's not talking. All right. So now we're going to learn how to do it with product rule. So in order to do that, guys, the first thing we're going to do is we're going to take it the old way, where we turned it into like a polynomial, and then we just use power rule. Okay? So if I have this one, we're going to rewrite this as a cubic, and you're all experts. So this is where we're going to take the 2x and multiply it through everything. So I get 2x cubed.
Why?
Why what? Because I'm multiplying 2x into that second bracket. Yeah, I'm going to do that next. Yeah. So now, then I take the -3 and I put it into everything. So now I've got -3x squared plus 6x minus 3. Why negative what? 4? 2x times -2x. Yeah.
So what is that? 6.
Okay. Then I'm going to combine my like terms. There's nothing to go with 2x cubed. So that goes by itself, but I can combine the x squared, so that gives me -7x squared. I can combine 2x and 6x to get 8x, and then minus 3. So all I'm doing there is gathering the like terms together. Would you agree?
Yes.
Yeah? Awesome. Once we have it looking like that, then we can take the derivative super easy. Because now we just use the rule from before that we learned, the power rule. Okay? So, to take that derivative, we do what we just did in the bell work. The 3 comes down, we get 6x squared, exactly. Then -14x plus 8. And the 3 just goes away because the derivative of a constant is 0.
And why does the x of
Because remember, this is like x to the power of 1, so the 1 comes down, and then it's x to the power of 0. Anything to the power of 0 is 1, so it effectively removes the x. And what does this represent? This is the slope of the tangent line. All right, so now I'm going to teach you what the product rule actually is, and we're going to do the exact same question so that we can see that they're the same. Okay? So let's write down what our product rule is. This just gives you a little bit of history on it, okay? I think actually you guys have already learned about Leibniz. Is that true? In like sociology class or something like that? I don't know. My students always tell me they've heard about him. And I hope you've heard about Newton. All right. So if we have like h of x is equal to f of x times g of x, meaning it's just two things multiplied together.
Where did you put?
I'm just giving you the definition of what it is. Then when we take the derivative of h of x, what we're going to do is take the derivative of the first times the second plus the first times the derivative of the second. No, it's not horrible at all. Plus, I'm not even making you memorize it. It's on the wall. Big 3. It's written in different notation, but it's the same thing. It's written with U's and B's. I just don't like the U and B one because U's and B's look the same. Then it's confusing, I think. But if we do it with their, like if we do the UV, it looks like this. So if we had, say, f of x is equal to u times v, then f prime of x is going to be equal to u prime v
No.
plus u v prime. No, I'm just showing you that's the one that's on the wall.
But when
Oh,
do
yeah,
you,
sorry.
when do you use that?
This is when two things are multiplied. The nice thing is that right in the name, it says product rule. Guess what? We use it when there's a product, when there's two things multiplied. So that's why here you can see no matter which notation I'm using, I have two things multiplied together. And then the way that I find it is by using this rule. Okay? Now, let's use that rule and let's prove that this one down here is the same thing. Do you guys prefer the blue notation or the green notation? They're the same.
Blue.
The blue one? All right. So if you're going to do the blue, let's rename this. Let's call this h of x. Let's call this part f of x. And let's call this part g of x, just so it matches for us. Okay? So then what we're going to do is we're going to find h prime of x. Now it tells us to find the derivative of f first. Okay? So if we look here, what's the derivative of f of x? It's just the power rule. Close. The 3 goes away, 2x just becomes 2. So it's literally just 2. That's f prime. Okay?
F, but why is it H?
And
Here, why don't we do it this way? Let's do it this way to make it
H
easier.
prime.
Yeah, let's do it this way. So we're going to write, it's f prime g of x. I'm just going to write the definition again to make it easier, okay? Times f g prime. Then we're just going to plug in what those things are. So the derivative of f, we just said, was 2. And g of x means we don't change it. It stays exactly the same. So it's still x squared minus 2x plus 1.
Entonces el menos 3 desaparece. And what's the derivative?
So hang on, let's do f first. So f is going to be 2x minus 3. Make sure you put parentheses. Now g prime is the one that's a little bit trickier. We got to do that. So the derivative of this, the 1 goes away. And what's the derivative of x squared? No.
I got it. 1, 0.
The 2 comes down. So 2x, right? And what's the derivative of negative 2x?
No, pero sí, 2.
Yeah, exactly. So we've got 2x minus 2 is the derivative of g. Okay, so g prime is 2x minus 2. The 1 goes away, exactly. Now, normally, you guys, you would basically be done. What I'm going to do, though, to show you it's the same as the one before, is we're going to go ahead and expand all this and prove it. You're not normally going to have to do that. So I'm going to do it so that we can see it, though, so I do still want you to do this. So, only in this one case, yes, not usually. And I'll show you why. The other thing is that we're done. I'm only doing this extra work now to show you it's the same.
But we don't have to put that. Yes.
I think you should write it out so that you know, yes.
But this would we need to do it.
Yeah, like normally, like we would stop here. Okay, we're going to keep going so I can prove to you it's the same as the way we did it earlier. So when we expand this out, it's 4x squared minus 4x minus 6x plus 6. That's just me foiling this one out. Okay, 2x times 2x, 2x times negative 2, negative 3 times 2x gives me negative 6x, and then negative 3 times negative 2 gives me the positive 6. Then I need to collect all those like terms. So that's going to give me 6x squared, negative 10, negative 14x plus 8. Yeah? Now, I want you to look up at the one above. What does it look like?
Same.
Exactly. So we got the same. Okay? So I agree that this one is a little bit more work this time. But we also could have stopped there and then it's about the same amount of work, if not less. Okay? But why do we care then, right? Like let's answer Tomas's question. Well, if we look at this next part here, look at that g of x. Can I write that as a polynomial? No. So I have to use product rule, right? I have to have some way to do that because I can't just make it a polynomial or something that looks like a polynomial. So that means that I'm going to take this and I would have to apply this rule. So let's go ahead and try that, okay? This time let's try the UV just so you can see the different ones. So we'll call this part U and this part V, okay? So U is x squared, V is sine x. So if we're taking the derivative of it, we know that it's U prime V plus U V prime. So let's go ahead and work that out now. So U prime, what's the derivative of x squared? You just did it. And you did it right. 2x, right? The x goes from x squared to just x because we always subtract 1 from the exponent. Times v, meaning it stays the same, sine x, plus u, so that one stays the same. And then we have to remember what the derivative of sine is, which we did in the work. What was it? Uh-oh. There we go. Exactly. Cos x. So the derivative of sine is cosine. And so there, now we can take the derivative of this even though we do not have a way to make it look like a polynomial.
So then,
And I think you can probably agree that wasn't that hard,
so
right?
that's the answer.
Yeah, that's the answer. That's the derivative.
I don't understand.
Which part?
Like, for example, here at the beginning, you
Uh-huh.
have to change it from cos x in x to cos y. Like this.
No, it should still be, it should have been cos x still. That's still x. Yeah, you don't change the argument inside. You're just changing the sign to cos, and then remember you change cosine to negative sine. Ah, my bad. I'll try to write nicer. All right. So then what we're going to do is we're going to apply this to a couple of these questions. Okay?
Do we know when to use which of these?
Which rule?
Yeah.
So you're going to use power rule pretty much all the time, anytime there's something with an exponent. But you're going to use product rule if two things are multiplied. So let's take a look at, say, these two first, because I think they're a little bit easier. So let's go ahead and do them, because we just did one like this, and it was pretty easy, right? So if we do this one, actually, you guys think you could try it on your own? It's pretty much the same as the one we just did. Okay? So what I'll do is I'll write it down, but I want you guys to try and do it on your own, because it's almost the same, right? It's not that different. So see if you can get it. And when you're done, look up and see if you got it. Because it's almost the same as the one we just did. Did you get it, Raquel? She doesn't want to tell me. Did you get Juanita sick, or did Juanita get you sick? Good? How many of you got it on your own? Anybody get it on their own? Looks like about 4 or 5 of you. All right. Good. If you had a hard time getting it, let's see if we can get it with a few more examples, okay? Perfect. Awesome. So let's take a look then at this one here, okay? So let's do the UV notation again, just because then I don't, well, no, you guys said you preferred the other one.
Do you know when to use UV and the other one?
Yeah, you can use either one. So I'll use the other one to show you. So we're going to rename this as h of x, just so that we can call this part. You like UV? Okay, we'll switch back to UV. They both work, so it doesn't matter which one. So we're going to say that this part's U and this part is V. And then let's start by writing out the actual definition of product rule. So U prime V plus U V prime. And then we'll actually take the derivative using those parts. Okay? Okay, so U prime, I think most of you got the first part. Let's make sure we get the whole thing though, because the 3 this time doesn't go away because there's an x on it. So it's going to be 4x plus 3. That would be my derivative of u. Okay. Then we just write v as it is, so x squared minus 3. Then I write u as it is. I don't change it, so 2x squared plus 3x. And now I multiply by v prime. That one's really easy because the 3 does go away this time, so it's just 2x. Now, you guys, I don't need you to expand it unless I tell you to in the question, okay? So if I say, hey, expand and simplify, yes. Otherwise, I'm fine if you leave it like this. I'll still mark it right if you simplify it, but I will also mark it right if you leave it like that. Okay? So you don't have to do all the simplification unless I specifically ask you. So, sometimes. Yeah, sometimes. But I mean, because it's not overly hard, but no, like I'm not going to ask you all that often. It takes a lot of time, which is why I don't always do it. Exactly. All right. This one is, let's do this one first, h of x. Now, why don't you guys try it on your own? Because it's actually similar to that first one we did again.
And how do we mark UV?
Okay, good question. So let's do that together first. So let's put this part here as u, and then the cosine of x as v. Now, if it helps you guys too, when you're doing this, like on the side, you can always write like u prime and v prime over on the side for you. So what is u prime? That looks a lot like 2 v's. There we go. So what is the derivative of just u? And what's the derivative of v? Nico, what's the derivative of v? Pay attention, buddy. It's negative sine. Knowing that, now I want you to try and solve this one, okay? So remember, it's h of x, or h prime of x is u prime v plus u v prime. So you should get this.
Why the parentheses?
Around which part? Around the 3x plus 2? I put the parentheses there because if we don't put it there, then it ends up not quite being correct because these are multiplied together, these two things.
Is there, why
What?
is it not 3 plus 2 then cos x plus 3x plus 2 then sin x?
Here? So this part here is because when we take the derivative, remember if it's just a constant, it goes away. The reason it didn't go away in our last one here is because it had a 3x. Whereas this one is just a 2, so the 2 goes away entirely. So that's why it becomes just 3. Now, there is one simplification here, Tomas, I am always going to ask you guys to do, and it's for your own sake. I don't ever want you to leave this with a negative in the middle, because somebody's going to think it means minus sine x. So whenever you have something like that, you're always going to move the negative into the front. Because the derivative of cosine is negative sine. So we have a negative there, so we're going to move that negative out front.
Why is it 3 cos x?
Why is it 3 cosine of x?
Yeah, at the beginning.
Because at the beginning, u prime is just 3, and v is cos x. So we're multiplying those two things together. And then for the second half, it's u times v prime.
And what happened to that 2 at the beginning?
At the beginning, it went away because the derivative of u is just 3. Because the derivative of 2 becomes 0. It goes away. Does that make sense, everybody?
Yes.
Yeah? All right. Now, I left this G one for last on purpose because it's a little bit tricky, because here there's a product rule and here it's just power rule. So it doesn't really matter that there's like, I guess, 2 of them. It's not a product rule in the beginning. It's still just 3x or 3 theta. Okay? So don't get confused by that just because you see things multiplied later. It's still individual. Okay? What I mean by that is like this is one term, so you do it by itself. This is another term, do it by itself. So Let's do well. Let's write out first. Let's do the product rule part. So let's make this u, and we'll make sine v. So let's actually write that out this time to kind of see it. So u is going to be theta, which means that u prime is going to be 1. And then v is going to be sine theta, which means that v prime is going to be cosine of theta, because we take the derivative. So then we can go ahead and we can plug this all in. So g prime of theta, 3 theta, what's the derivative of that? It's the same as 3x. What happens to the x there? Yeah, so it's just 3. Plus, now we have to do the u prime v, right? So now we do that whole u prime v plus u v prime, okay? So what part? The 3? The 3 comes from here because the derivative of 3x or 3 theta is just 3. Because you can think of it as the fact that it's like 3 theta to the power of 1. The 1 comes down, and then you get theta to the power of 0, which means it just becomes a 1. Okay, so u prime, that's just 1. And then v is sine. Plus u is theta, and v prime is cosine of theta. Now, do I need to put this 1 in front of the sign? Do I have to have it there? No, I can. It's not wrong. So if it's easier for you to think of it as being there, leave it. If not, take it out. It just means 1 times sine, which is just sine, right? But that would be our derivative now. How you guys feeling? Making sense? Yeah? All right. So the thing we often end up doing, right, I've done this quite a bit, is we do like tangent lines. Derivative is the tangent line. So finding tangent lines is something we do a lot. So here we're going to find the equation of this tangent line, okay? Anytime you hear tangent line, you should always be thinking pot and saw. So our pot, it tells us it's pi. And then for, like, to find the y, I need to plug in pi into g. So it's just going to be pi squared cos pi. What is cosine of pi, if you look at the unit circle? Cosine of pi. There you go, -1. So this is literally just going to be negative pi squared, right? Because it's pi squared times -1, okay? This part here becomes -1. And this part here is just pi squared. They're multiplied, so that's where we get the negative pi squared. All right. Now, to figure out my SOT, I need to actually take the derivative now. So let's go ahead and do that. So g prime, what's that? Because if I plug in pi for t, then it's just pi squared. Okay? Now, we need to come up with our u and v again. So let's make the t squared u, and let's make cosine v. Does it help you guys if I write on the side what the derivatives are? Do you want to do that? Yes, no?
Yes.
Yes? All right. So u is t squared. U prime is therefore 2t. And then v was cosine of t, which means that v prime is negative sine t.
So by likewise, u prime 2t is supposed to be like no.
You're okay? All right. And then we're going to go ahead and do u prime v plus u v prime. So we can kind of write out, you don't have to write out the definition, guys, but if it helps you, then I would suggest write out the actual rule. Yes, Raquel. Because the derivative of sine is cosine, and the derivative of cosine is negative sine. That's one of the ones that I told you we just kind of have to memorize. But it is on my wall back there. Maybe we should just take down Andres's poster so we can see it
I
better.
just don't know where to put like parentheses. Like once I'm putting all
If you're unsure, put it around every term. Put it around every u, prime, v, everything. Okay, so u prime is 2t. So like if you're unsure, just put it around everything, like this. And then for v, that's cosine of t.
And that would also be like correct.
Yep, still correct. And then we do u, which was t squared. And again, if you're unsure, just put a parentheses around. It's not going to change it. V prime is negative sine t. Because you'll find what I do, Marianne, is I put it where it's really necessary. Like in this one, the only place I would put it if I wasn't like putting it on everything would be around the sign. And it's because I need to know that these are multiplied, not subtracted.
We need to change it to negative.
Exactly. The one thing I'm always gonna ask you to do is move that negative forward. And so then instead of plus t squared sine, it's gonna be minus t squared sine of t. Like so. And again, if it helps you like put parentheses around everything, it's fine. There's nothing wrong with doing that. All right. So we have the derivative, but remember the whole point of this was that we actually needed the slope at a specific point at pi. So what we're going to do is find g prime of pi now. And so then we're literally just going to replace every single t with a pi. So I'm just going to rewrite it with pi's everywhere. I'll let you catch up. Once you have caught up, try to figure out what cosine and sine of pi are. We just did cosine, so you should remember that one. But see if you can remember what sine of pi is. So we know this one's 1, or negative 1, sorry. What's this one? The sine of pi. What's sine of pi? If you look at the unit circle, if it's not 1 or negative 1, what is it? 0. So if this is 0, what's anything times 0?
2.
This whole side is just going to go away, right? Because it's times 0. So that's kind of nice because then we're just going to get negative 1 times 2 pi, or negative 2 pi. Again, let's just move the negative to the front, because if I write it like this, somebody's going to write 2 pi minus 1, and that's not the answer, okay? They're multiplied. So write it as negative 2 pi, like so. Okay, so that's my SOT. Now that I have all that, I can go ahead and write my equation, right? So remember, this was where we did y minus y1 equals m x minus x1. No, Nico, you've done this lots, man. What do you mean, man? That's the way we write a line. You've been writing lines like that since like... No, this is the whole thing. The slope we just found. Because remember, what is... Guys, what is the derivative? It's a negative 2 pi in this case, but what did I yell at you and make you yell back at me? What is... It's the slope of the tangent line. The derivative is the slope of the tangent line. And then I yelled the slope of the tangent line, you had to yell at me the derivative, right? So, that's what m is. M is the slope of the tangent line, so it's just the derivative. So this is y minus negative pi squared, so y plus pi squared, equals negative 2 pi times x minus pi. Okay?
So the answer would be
This line.
this.
That is the equation of our tangent line.
So when they say what t is pi in the first one is
It's always whatever they give you. Yeah. The x value is always whatever they give you.
Then we reemplazamos.
Yep. Yeah, exactly. Then you replace to find the y, and then you find the derivative, and then replace it to find the slope. But these are pretty common type of question. I'm going to ask you guys to do this kind of thing. Okay? All right, so let's put this into a little bit of practice when we have some graphs. Make it a little more interesting. Okay? So what we've got here is f of x and g of x, and then we've got this function p of x, which is the two of them multiplied together. Okay? So we're going to use that to be able to figure out, like use these graphs to be able to figure out what these are. So g prime of negative 4 is 2, and they want us to find p prime of negative 4. So the first thing we're going to have to do then is find just p prime of x. Now remember, p of x is f times g. So let's write out what it would be. It would be f prime times g plus f times g prime, right? where f is u and g is v. That's all we're doing. That's the same as like that u prime v plus u v prime. Same thing.
Better you and me.
No, that's fine. I did it this way just because it's literally written as f times g. Okay? So we've got the derivative essentially already now. We're done. Now we got to plug it in. Okay? So the second part is to actually plug in that -4. So to begin with, let's just plug it in. Let's not make it complicated. So -4, g of -4 plus f of -4 and g prime of -4. Now they gave us g prime of -4, so that's one that we can just do. They didn't give us f prime. Now, usually if that happens, guys, it's because I'm going to give you a straight line, a linear equation. Because what's the slope of a linear equation? How do you find it? You've been doing it since grade 7. How do you find it? Rise over run, y2 minus y1 over x2 minus x1. Exactly, right? So if we look at -4 here, yeah, that's exactly what it is. It's right here, and it's on that equation. What is the slope of this line right there?
1/1x.
Close.
2 over -1.
-1. So it is 1, but because it's going down, it's negative, right? Or 2 over 2, you'd get the same thing. You'd get -1. So this one's going to be replaced with -1. Then we need to find g of -4. That's not a derivative, so we're just finding the actual value. So here's -4. We go up. It's right here, and that is at this value, which is, it's hard to see it there. Look on your page, maybe. I think it's a 6, isn't it?
Yeah.
1, 2, 3, 4. Yeah, it's a 6. So that would be 6. Then they want f of -4, which is right here, which is at -1. And then we've got g prime of -4, which they gave us because it's a curve. We can't find it ourselves. They had to give it to us. So this is 2. And then all I need to do is simplify that. So -1 times 6 is -6. -1 times 2 is -2. And so finally, p prime of -4 is simply -8. Make sense? Yeah? All right. So then, like I said, we often do tangent lines. It's going to ask us for the tangent line. Well, we just found the derivative. So we already found our SOT. So if we are looking for pot, it's -4 something. We'll find the other side. And our SOT is -8 because it's still at the -4. It's at the same value. So that means that all I need to do is find p of -4.
Why is it negative?
Because we just found it, right? Yeah. So p of -4 means that it is f of -4 times g of -4. Now, we just found both of those. What was f of -4 if you look in the previous question? -1. And what was g of -4?
6.
6. So that's just -6. So our pot is -4, -6. And so then we can just write our equation. Y minus -6 is the same as y plus 6 equals the slope times x minus -4, x plus 4. And again, this is just coming from this equation that we've been using.
Okay, break.
Or, all right, so we're letting Raquel finish. She's madly writing. Look at her go. All right, so our next one, oh, no, sorry. The other type that we often do, guys, is I'll do tables. Because with a table, you kind of have to know what you're doing. And if you do, they're actually easier. If you don't know what you're doing, I'm not going to lie to you, the table questions are going to make you want to die. But if you know what you're doing, the table question is easier, okay? So let's take a look at it together, okay? So first of all, estimate the value. We always did that with the secant line, right? So let's go ahead and do 3.5. That would be right here. That's 3.5. So the 2 points I'm going to use are going to be 4 and 1 and 3 and -2. That is really ugly. Let's just write them down here. So the points we're going to use are 4 and 1 and then 3, -2, and we're going to use those to find the secant line. So that means it's, sorry, not the secant line, the slope of the secant line. So that's going to be y2 minus y1, just like Mara's just said, over x2 minus x1. Okay? So we plug that in, negative 2 minus 1 over 3 minus 4, and we get negative 3 over negative 1, which is really what? If we simplify those negatives, what is that? Yeah, right? The negatives cancel, and then dividing by 1, why bother? So it's just 3. Done. Done. Okay?
And then what does that mean?
That's just the approximate slope. That's the slope approximately, right? So I guess like if you wanted to write a statement, you could say f prime of 3.5 is approximately 3. Okay? Now our next one, it's the same kind of question we just did, except there's this extra 2. So there's this extra 2. So p prime of x, let's always just start by finding kind of the definition here. So it's negative 2, and then let's deal with the fx gx. So remember, it's the derivative of the first times the second plus the first one times the derivative of the second.
Why is it in brackets?
Because the negative 2 is outside of everything. So once we're done, we're going to multiply our final answer by 2, or negative 2. But remember, we're actually finding p prime of 3. And so then, do you want me to rewrite it with the 3's, or do you want to just find what they are?
Find what they are.
Okay, so f prime of 3. Let's go look at our table. F prime of 3 is negative 4. Do you see how I'm doing that? Okay, so if you like I said, these table questions are actually easier if you understand them. Now, what is g of 3? Whoa, that was weird. G of 3 is negative 3. And then I'm finding f of 3. So let's go find that in the table. F of 3, negative 2. And what's g prime of 3 now? G prime 3 is positive 2. Okay, so then let's just simplify that. Negative 4 times negative 3, positive 12, sorry. And then negative 2 times 2 is negative 4, which means that I've got 8. And then that's just negative 16. So p prime of 3 is just,
We need to put it in brackets.
say what?
We need to put it in brackets.
Which part? I would put this part in. It's just to show that at the end we need to multiply negative 2 by everything. So yeah, it's a good idea.